Okay, so great. I don't want to. I'm lazy. All right. So we had, I think, what was it? It was number. Was it? Oh, actually, I have it right here. It's number and then the unit. We have number measured in balls, and then we have mass measured in grams. I don't know why I had to look that up. Okay. So I just want to point some things out. Mass and the hashtag sign in the olden days, that hashtag sign that you can barely see. In fact, let me just move this all over. That hashtag sign it just represents the number, right? So the variable is the number, and the unit is spheres or balls, right? And then we have mass, which is the variable, and gram, which is the unit. So you need to remind me. I forget what we recorded. So let's just go through the first column for the number. What numbers do we have? We'll just go straight down it. 1, 5, 7, 11, 9, 6. That's it. Okay. Mass. 331. 445. 501. 666. Who's this guy? 668. Sorry, my hand slipped, guys. Okay, next. 474. So a couple things. Does it matter that we are not in order here in the data table?
No.
Does that affect our overall graph?
No.
No, because it sorts itself out. Or hopefully it does. If you don't know how to graph, it might affect you. But that's the point of what we're doing today. So to give you an overall view of what we're doing, we're just going to use Excel to graph scientifically. Many of you, how many of you graph dot to dot? Okay. Put your heads down in shame. No, I'm just kidding. What we're trying to do is we're trying to make an overall trend. Right? What we're doing is essentially, I'm going to show you how physicists and mathematicians and scientists get those like many equations that you have on your equation sheet. And we're actually going to be making one of them right now. So we have these two. What we're going to do is we're going to graph this. So usually the fast way to do it, which I will allow you to do later, is usually you can like highlight your data and then you can just create graph. But right now we're going to do it without doing that. I want everyone to start with a blank sheet because once you know how to manipulate all the data, then you can do it the fast way because I'll know that you know how to manipulate it. So everyone, let's go to insert. Just if I do something different, then just make sure you're doing what I'm doing. So we're going to be going to scatter plot, and we want the scatter plot without the dots. Or sorry, without the lines. Without the lines. We want the dots. The dots are the data points. We want those. When I click on that, for many of you, maybe you see that there is nothing on your graph. If you see that, you're ready to go, you're good. If you don't see that and you actually see a graph, you are wrong. You're not wrong. We just have to change that a little bit, and I'll show you how to change that. But whatever is output here, if there's a graph, if there's not a graph, it's fine. Okay? So what I did, just to recap, I went to insert, and then I went to scatter. And I went to the first one. And please feel free to help each other. Like if you are like super confused, see what your friend is doing, ask your friend for help. Let's be friendly. So we did that. Now what I want everyone to do, click on your graph, left click on your graph, and then right click on it. It doesn't matter where, just right click on it. We want to go to the option select data. And again, if you already have a graph there, it's okay. Select data. Okay. If you have data points on your graph, I want you to remove all your data points. So there should be an option for remove. There might be like a checkbox or something here. Just click on your data, remove it all. I want it all gone. As you do that, you will notice that your data table, or sorry, your graph is blank. After you remove your data, your graph should be blank. It updates live. Is everyone cool with that?
Yeah.
Okay, great. We're going to add the data now. And this is how we add the data. Make sure you have access to being able to click onto these, like make sure graph's out of the way, stuff like that. We're going to go to add. Our series name is going to be our dependent variable versus our independent variable. And in fact, that's usually how we're always going to title our graphs, the y versus the x. So when we're looking at this, which one is y, which one is x? What do you guys think? Let me get one person to answer that. You got yeah? Okay, yeah. What do you think? Just it's okay. Yeah, you're right. Right? Because the number of balls determines how much mass we have. Yeah, stop laughing. No laughing. It's not funny. So we're going to say then it's going to be mass versus number. And you can have just the hashtag. You can write number if you want. I don't care. Maybe when you're in college it'll matter a little bit more, but for now it's just that. So we have mass versus number. That's the series name. Okay, let's go back. I clicked on add. Add. Yes. Oh, you're just stretching? Okay. All right, so now, oh yeah, okay. You can just make a new graph and just follow along with us. So if we start doing something different, if you know what we're doing, great. If you don't know what you're doing, then you should follow along. Okay. So for our x values, we're going to highlight only the numbers. So our x values, is it the mass or the number? Number. So we're going to make sure that this text box is clicked and we're going to highlight. So let's watch that one more time. It is clicked here, and then it is highlighted here. You're going to do the exact same thing for the y values, except just be careful. Make sure that part is deleted. And you'll notice it'll graph it very much live. So your data table should look actually exactly like mine. If it doesn't look like mine, you've messed up somewhere. Ours will have a trend line in a second. It's because you have a different graph type right now. So it automatically calculated yours. So I'll give you all a second there. You're going to be using like these skills, like every project we do, we will have a graph. And you will make a graph, yeah. All right. Can I press OK? No. Okay, I'll wait then. Okay, I'm gonna press OK. Now notice we have data and we have this box here. We're done here. If you ever want to add if you want to have multiple graphs, multiple trends on the same graph, you can just keep adding different data. Or you can do it over and over and over again. Like for example, don't copy me. What I'm gonna do right now, just don't copy me. Right? So if I wanted to, let's say I wanted to make a different graph, and then what I'm basically doing is I'm just reversing these. But now I actually have two separate graphs, and it looks really bad because those graphs are basically like zoomed in. Yeah, one's really, really far in the x direction, one's really, really far in the y direction. But, and sorry, I guess this is a bad representation, but that's how you would have multiple graphs. So we're just going to press OK for now. Great. We have a graph that is not even close to being done. But it has a title, and it has data points, and the scale is like pretty okay. All right. Next, here is the cheat way to make a scientific graph. Click on your graph. Click on design. So I clicked on my graph. Clicked onto the design tab. I clicked on quick layout, and I'm going to layout number 9. Wow. In your mind, you're like, man, last year I had to make a graph with the trend line, and I had to like YouTube it and no, this is it. I get it now. Literally, probably this is the most useful skill I'm going to teach you all year, probably. No. All right, so I'm going to click on that. Bam, you have one graph. I don't care about this. We don't need to keep, we have one graph. If we had multiple, obviously we would need to keep. We don't need it right now. Let's get rid of that. Bam. Let's talk about some of the equations and stuff up here. So you can edit these, right? So let's say that first. Let's say I only really care about like to the 10th place, then you can just write 32.4 plus 285.7, whatever. Does anyone know, what does this r squared value mean? All it means is how well your trend line matches your data points. So if I had a data points that were all 100% on the trend line, I would have an r squared value of 1. If none of my data points were even close at all to my trend line, then I would have an r-squared value that's very small. How does anyone know? How do you get an r-squared value of 0? Which would be to say that there is no effect of the y and the x. What kind of line tells you there is no cause and effect relationship? Horizontal one. Who said that? Yeah, horizontal line. So the only way you get an r-squared value of 0 is if you have a horizontal line. An exact perfect horizontal line. So no matter what, even if you had data points where someone like literally played darts and just like tried to make data points, you still have some type of r-squared value. But closer to 1 is good. Not close to 1 usually means that there's a you either did a bad experiment or maybe there is no relationship. And that's okay. If there's no relationship, that means that variable y does not affect variable x. That's a fine and okay result. Okay. This next part, I want to talk about what will happen. Okay. So I think we can do this first. Let's label these two, and then I'll talk about what will happen next. So we should have a label and a unit. Sorry, that little option on the side, it just kind of popped up because I double-clicked too many times. All I did was I edited the label. And keep in mind, obviously, if you're having trouble following along, this video will hopefully be up today. It'll probably be unedited because I'm lazy. But you can watch it at like double speed. And, get
voices
this.
being it?
Yeah, voices. Yeah, right now. Yeah, say hello to yourself.
Shalom.
Potatoes.
Potatoes, that's who you play against in Fortnite. Okay, anyways. What we're doing next, we're going to do 2 things. 3 things. We're going to extend the trend line both directions so that it can like make predictions. And then what that's going to cause is our axes are going to change to fit the trend line. And then we're going to set the bounds of our axes so that it only displays what we basically have right here. Okay? So we're going to do the trend line part first so that if you ever do that in the future, you don't panic when you change it and whatever. So with anything else in Excel, if we want to change something, we right-click on it. So let's click on our trend line and then right-click on it. We're going to go to the Format Trend Line button. You do that, and you have an option bar that comes off to the side. Notice that there are very different options, exponential, linear, logarithmic, whatever. If you click on them, they can give you sometimes better r-squared values. So this one gave us, actually, we have a better match with this exponential, right? 0.9945. But if we think about the lab we did, there's probably not an exponential relationship, right? If we keep adding those marbles in, we're not going to start going up at some like crazy exponential rate. This isn't. Yeah, it's not. But for whatever reason, right? For the data that we do have, it is a better match. If we go to logarithmic, not so good, right? We get 0.8. If we go to polynomial, 0.992. Power, again, not super great. Moving average, I think, doesn't have we will never use moving average, ever. For this case, though, we're just looking at linear. So just so you know that's there. We're going to go down to the forecast. Literally, forecast means like you're making a prediction, right? You forecast the weather, right? We're going to forecast, usually you can just do 5 periods forward, 5 periods backwards, and then that'll be enough. 5 and 5. So notice, again, now our data is here, but our trend line has stretched out, and because Excel is the way that it is, it also stretched out our axes. You can imagine the way that we're going to change those is just by right-clicking on them, and then we'll just set the bounds. So again, all I did for my trend line, right-clicked on it, went to forecast, made it 5 periods forward, 5 periods backwards. That's it. That's all I did. If you don't see yours change, it's because you're still in the text box, right? So for example, I changed my forecast to 0. It hasn't changed because I'm still in the text box. When I click out of it, bam. Okay. So now the next thing that we can do is oh wait, sorry, I need to. There we go. Okay, I need to change the. Let's change the x-axis first. If you want, I think you can just click on this. Click on the axes. I guess that doesn't help. We're actually going to right-click on the x-axis and then go to Format Axis. make sure there's this box around it first. Right? So to recap, I click on the x-axis first, and then I right-click on it. And that'll just ensure that you're clicking on the right thing. And then you can probably tell we're just going to set our min and our max. Right now it's set to auto, so it'll change as we change our data. We're just going to set our min and max. We want 0 for minimum. For maximum, we'll say, let me just eyeball it. 15 is good, so I'll do that. Keep in mind, graphing is the reason we do it is for human beings. So you want to make a graph that looks good and that does not misrepresent your data. That's actually why in this class we'll never, unless you like, there are some cases where you might use a break, but we will almost never use breaks, which is like skipping data. Now let's do the same thing for actually the y. Do we need to change the y? I think the y is actually pretty okay, right? Yeah, and maybe just for the sake of doing it, let's just change it to 800. So this time I think we can just click on the y-axis, and we'll just change it to 800. That's pretty good though. All right, you can exit out. This is a complete graph. If you want, I'm going to edit my equation a little bit, make it a little bit simpler. Let's do a 4. Okay. Bam. I don't care where you put your equation. You can put it like in the middle or whatever. You can put it, I don't know, at the bottom. I don't care. Just make it look good. Make it presentable. Pretend you're introducing your parents to it. Okay. So great, you've constructed a graph, but if you can't understand it, who cares, right? So that's what we're going to talk about now. We're going to talk about understanding these graphs and making sure that they are the way that they should be. And we're going to make sure we understand why they are the way they are. So, from yesterday, we had the Mr. McNair Foundation for Underprivileged Teachers. Feel free if you want to ever add money in here. You pretty much can just tell me, and then I'll open my wallet, and you can just stick a 20. Okay.
Will that improve our grade?
Let's just say, so like, I know there are some times when teachers say like, hey, this is not extra credit, it's just, for your benefit. You guys do extra stuff for us, and we like you better. Like, I mean, when it comes down to grading time, it's like 92.9. Like, should we give you the 8 or the B? We're going to give you the 8. It's just going to happen. Let's be honest. We're human beings too. I'm not trying to say it's favoritism, but if you're a student who's like, makes a teacher's life like hell for the entire year, and you're at a 92.99999, I'm like, oh, I mean, that's not an A. So it's close, but it's not an A. Should have done that homework assignment.
My contribution while you're
No, wait, you guys are messing up. Messing up the data. Sorry, I only accept 20 advice.
I am
underprivileged guys. You want to make an impact and a difference. All right. Anyways, okay. Let's go back to the measurement lab. So, save this, and then you're gonna throw it on top of your measurement lab. Let's talk about Word for a second, because there are some things that maybe you don't know about. So let's just copy this. Okay. Let's go to that measurement lab. First up, you can just delete this graph. Okay. You can delete this table, and then let's paste. Bam. So there are different paste options. I don't know if you know this. Right now, I think this is pasted as it is connected to Excel. What that means, so let's check this guy out. This one is at a little bit above 300. If I change it in Excel, say it's like 250. So notice that dropped. Let's check it in here. Notice that dropped as well. Okay. Sometimes you don't want that, right? You're done with the graph. You don't want to change anything. So, what was it? 331, right? Instead of pasting it, just doing a normal copy paste, let's right click and then paste as a picture. There it is. And then of course, it messes with the formatting. This is how we fix that. When you go to click on your picture, there'll be this little part called layout options. we just want to go to usually the last two is pretty good. Behind text or in front of text. We're gonna do in front of text now. If you do behind text, sometimes what happens is it gets behind the text and you can't click on it. And then you're just like, ugh. But if it's in front of text, it's fine. So let's see. Okay, so now it's over here, but now we can move it really freely, right? It's not adjusting the text. You just throw it down in here. And we good. Maybe make it gigantic because we have the space. Bam, look at that. Look at that beautiful looking graph. Nice. Okay, so now we're going to try to understand what it means. Okay, we're going to do it in context of balls in a can. Okay, so the y-intercept is the mass when there are no marbles in that can. So how come our graph doesn't go to 0? Can anyone raise their hand and tell me? Diego? It's the mass of the can, right? So if we're looking at our graph, approximately, what is the mass of the can? What's it? 300, 200 something. So let's look. It's a little bit above, below 300. If we count, there's 1, 2, 3, 4. There's 4 of these, so it's like 25. So this would be like 275-ish. Maybe like 276. Okay, let's check and see if that's true. This is the part of science where we're predicting, right? Right. This one says 302. How close is that? 302 and then 275. Let's actually calculate that. We're going to do the error calculation. So, you probably need this. So we said it was 276. So 276 grams was our experimental value. 301 grams was our measured. Okay. What we're gonna do, and actually we would actually call this theoretical, but we're gonna say measures now. What's up? No, we're just figuring out. Oh, that was really loud. I don't know if you guys know this, but if you go like this, you can like hear better. So when I just said that word, it like echoed into my ear really loud. Okay. Anyways, so we're gonna calculate the percent error, how much our prediction was off. All we're gonna do is we're gonna take the absolute value of 276 minus 301 grams, all over 301. Right? Okay. If I subtract things with like units, does the unit go away? No. What if I divide them? Will the unit go away? Yeah. Denise is like, she's kind of sure. But yeah. So let's do this. Someone calculate this for me. Tell me what you get. But, yeah, use your calculators, yeah. I mean, you can do like long division it. I need a decimal though. Oh yeah, you use 1 note, whatever. What'd you get? 0.083. Okay, what is this in percent? 8. Cool. So we have an 8.3% experimental error. That's pretty good. Well, in average in this class, if you're getting less than 15% error, you're like probably okay. Some scientists, like when they're doing these like crazy experiments where there's so many different variables, they're getting like less than like 1% error, which is amazing. But anyways, great, we have that. We're gonna do this calculation one more time with something else. So let's write that in together. It's the mass of the can or the jar, whatever. Whoa, what the heck? Okay, and then so the mass of the jar using the graph, we said it was like 275 about. I know I said 276 up there. It's whatever. Like, look at your graph and determine for yourself. It says to find the units of the slope, take the units of the y-axis and divide them by the units on the x-axis. So literally, this is like, what are the units on the y-axis? Grams. What are the units on the x-axis? So what is my unit of the slope? That is completely wrong. Grams per ball. Why didn't I just use the line as the division sign? Grams per ball. So, in English, can someone tell me what that even means? What does it say at grams per ball? Yeah, how much mass each marble has. Okay, so what was the slope? We're going to skip all this other parts over here, so then we'll go to slope. What was the slope we found? Eight. Huh? Yeah, just use the slope they gave you. So what was the slope? 32.4 what? Should be 32.4, what's, not just grams per ball. So say 32 point, was it 7, 6? I forgot already. 7? I can't even hear people. I'm not gonna lie. 4. Okay, Gary. I don't have good hearing, so 32.4 grams per ball. So what does the slope tell us in this case? And there's one special word that you need to like have in there for it to be correct. What does the slope tell us? Similar. Oh wait, did we do in this class? I don't know if we did in this class. But does anyone know? What does slope tell us in this case? Huh? Not just the trend. What is it? Who said it? The average. It's the average mass of each ball. Okay. So anytime we have a line of best fit that is just a straight line, not a curved one, but a straight one, that represents the average of your data. Like 100% represents the average of your data all the time. So it says the average average mass of each marble. So on average, and we'll put them back in there, they should have a mass of about 32.4 grams. But is that going to be the case for every single marble? No. And in fact, really, none of them are going to be 32.4 because I use two different size marbles. So let's weigh them. I have this one. So I'm going to 0 it. So now it says 0 if I put this in. So the smaller ones are 28 grams. So about 4 grams off. Let's see here. I'm going to do one of the tarnished ones. The tarnished ones are 30 grams. So pretty close. And then let's do one of the bigger ones that I used. These are a lot heavier. It's about like 50 or something. 68 grams. But I only ever use 2 of them, right? So I use, 9 of the smaller ones, and then 2 of the bigger ones. And so the overall average of all, basically 11 of those was probably around 32.4 grams. Cool, so that's a pretty good prediction. Let's work with the smaller one. Let's see our percent error. So the smaller one is now saying 27 grams. I want you to calculate our percent error in the prediction of our small marbles. So this will be our experimental value, 32.4. And what we measured is, it says 29 grams now. So 29 is our measured value. So I want you to do the same calculation we had over there. Give me a percentage of the error that we have. So we have 32.4 as our average, 29 as our measured. Yeah.
So I did this yesterday, and I had 29 grams for my slope.
Yeah.
And that's what I found.
Okay, that's fine. So yeah, you still do the experimental error there. You don't have to do it on that page. You can just do it separately. Yeah, and if you already answered all these questions and stuff, and you're close to what I have, you don't have to change it. Ooh, you guys gotta ask these things. Huh? We will. I want to make sure everyone is good to go though. It's just for now though. This is for now. I'm trying to make sure we're all at the same base point. What? All right, so can someone help me out? What did we get for our experimental error? 10.5. 10.5%? Okay, cool. So what we got is 0.105, right? And then now it's cool. Again, that's not bad. Cool. So again, help me out. What is the average mass of the marbles? 32.4. Okay, great. And this is again like a reiterated question, but why doesn't the graph go through the origin again? Let's do someone on this side. Miles. Why? Don't let. He's got it. He's got it.
It's because the can. You gotta measure the can weight too. So.
Yeah, that's exactly right. The can's weight. Right? We have a starting value that is the can's weight. I didn't zero it to begin with. Right? Man, you guys have no faith in that guy.
Good job.
I believe in you, Miles. You got this. What?
When you become great, remember me.
Yeah, remember me too. I'm just a poor teacher with a empty fund over there.
Well, I gave you $1.
I only accept 20s and 50s. Come on. All right, that is all I care for you to answer because the last question is literally just doing this. So let me end this recording. Everyone say bye.
Bye.